Good evening, everyone. Good evening, everyone. I hope we're all well. Okay, so in this evening session, we're going to be looking at the last part of cubic functions, mathematics paper 2. In the previous session, we looked at those types of questions where they give you, like they draw the graph for you, and then they ask you those follow-up questions. In this session, we're going to look at those other types of questions where they simply give you a table of values and then they ask you to draw the graph after finding the missing coordinate. Yeah, but before we get to our lesson for today, allow me to make mention that we are currently going to be having a couple of crash courses. This initiative is meant to help those who haven't done much to catch up, okay, or those who want a distinction, okay, like a distinction guaranteed. You just want to perfect everything, and so you are also welcome to jump on board when it comes to these crash courses that we're going to be having. So we are going to start having these crash courses tomorrow, Monday 22nd of June, and this is the first one we're going to start with. So it will run from 20 hours to 24 hours, and these are the topics we're going to cover. So under algebra, we'll cover everything, okay, starting from simplifying expression, factorization, difference of two squares, algebraic fractions, quadratic equations, and then we'll proceed to indices, and then seal it off with arithmetic progression. Okay, then on Wednesday, we're going to look at these topics here. We're going to look at functions, variation, quadratic function graphs. The timing is the same, 20 hours to 24 hours. And then on Saturday, we are going to look at calculus, coordinate geometry, area of a sector. Then finally on Sunday, we're going to look at matrices, F geometry, inequalities, speed time graphs, but the timing is going to be different for Sunday. We're going to start at 14 hours and we're going to end at 18 hours. So this crash course is for mathematics paper 1. As you can see here, it's indicated mathematics paper 1 crash course. Next week, that's when we're going to have mathematics paper 2 crash course. So if you know that you maybe started learning with us late and you haven't covered most of these topics, this initiative is meant to help you. Okay, it's only 40 kwacha per student for each crash course. So for the Saturday one, it's only 40 kwacha. For early bird registration is only 30 kwacha. So the first 10 people to pay will be charged at 30 kwacha each. Okay, after that everyone will have to pay a 40 kwacha. So this is for paper 1. Okay, we're going to have a total of 4 crash courses. So you can see here, this one says 104, this one here says 204, and then finally we're going to have these two that are also saying 304 there, and this other one is saying 404. Then we're going to proceed to mathematics paper 2. So if you know that you need help, please jump on board. This is the best we can help you. Okay, so that is that. We now proceed to this evening's business. So our first question is coming from mathematics 2024 paper 2, and it reads, answer this part of the question on a sheet of graph paper. You're supposed to answer the entirety of this question on a sheet of graph paper. And the question goes on to say, the values of x and y are connected by the equation, that equation over there. Some corresponding values of x and y are given in the table below, in this table right here. So for this type of equation, they'll always give you a table of values and then they'll hide one of the values. Okay, usually for the y, a corresponding value to the y coordinates. Okay, so the coordinates up here, all these coordinates in this row are for the x axis, and then these ones, that is for the y axis. So since your equation has an x in it, okay, they usually hide the coordinate on the y side. Okay, so now this coordinate is very easy to find. All you have to do is you get the original equation for the graph, this one right there. Okay, and then in this original equation for the graph, you'll need to check the coordinate you're trying to find. It is the k here, which is corresponding to the y coordinate. So all you have to do now is you get the corresponding coordinate for this k. The corresponding coordinate is basically the coordinate right above it here, which is on the x part. Okay, so in this case we get these 3, and then we go to this original equation. Wherever there's x, we plug in a 3. Even there, we plug in a 3 and solve. The coordinate we're going to find is going to be the value of k. So they said answer this question on a sheet of graph paper. So I'm going to answer that question right here. So we're going to label. So this should have been question something. So I'll say, let's assume it was question 10. So I'll say question 10, A, Roman numeral 1. And then we said you get the original equation for the graph, which is x cubed minus 6x plus a 2. Okay, the corresponding coordinate is a 3. So wherever there is x, I'm going to put a what? A 3. So I'm going to say 3 cubed minus 6 times 3 plus 2. Okay, when I punch those values, what am I getting? Okay, so that is 3 to the power 3 minus 6 times 3 close bracket plus 2. I confirm that I have punched the correct values. 3 cubed minus 6 times 3 plus 2 equals, that is giving me 11. So meaning the value of k is equal to 11. So y is equal to 11. Therefore k is equal to 11, and you are done. You've gotten that 1 mark. We now proceed to the next one. So now here it is very important for you to know how to interpret the scale, because they are going to give you, sometimes, especially for this question, they will give you different scales. Okay, you need to know how to interpret the scale. This is also going to help you the time we'll be looking at linear programming, which is basically in the next session. It is important for you to know how to interpret the scale they're giving you. So here they're saying using a scale of 2 centimeters to represent 1 unit on the x-axis. Okay, so 2 centimeters is basically the distance from there to there, or the distance from there to there. Simply put, one big box. Okay, from one corner of the big box to the other corner, that is 2 centimeters. So since they are saying using how many centimeters? 2 centimeters to represent 1 unit on the x-axis, meaning if we have 0 here, our 1 is going to be there, 2 will be there, and our 3 there, because this is from there to there, it's 2 centimeters. From there to there, it's 2 centimeters. So we have been told to use 2 centimeters to represent 1 unit. Okay, that is that for the x-axis. Okay, let me also talk about the y-axis before I come to this. Okay, then on the y-axis they're saying and 2 centimeters to represent 5 units on the y-axis. So on the y-axis, let's say this is our y-axis, this line right there, this line. Okay, if we have 0 there, meaning we need to have 5 there. Okay, and then 10 there, since they are saying 2 centimeters to represent 5 units. Okay, so meaning from here to there it is 5 units, from there to there it's also 5 units. Okay, so now after you are done interpreting the scale, they will now give you a range for each axis. For the x-axis, they are saying the range is from -3 to +3. That is the range for the x-axis, and then the range for the y-axis is from -10 to +15. all right, so that is that. So now we need to plot this particular graph. So let me just use a black pen for the y and x-axis. So let us put our values right here. So the y-axis, what is the range? It is from -10 to +15. So usually for this type of a graph, it is mostly centered, like centered right in the middle of your graph paper. So the range is going up to 15. So I can say this is 15 here, right there. That's my 15. They said 5 centimeters to represent 2 centimeters to represent 1 unit. So if this is 15, meaning here I have 10, and then there I'll have 5, and then there I'll have a 0. The range is from, remember, the range is from -10 to +15. So -10, 15. We have started at 15, so going downwards we should end at -10. So there we're going to have -5, and then they are going to have negative 10. Okay, that is for our y-axis. When you go to the x-axis, what is the range? The range for the x-axis is from negative 3 to positive 3, and then we're told to say 2 centimeters represent 1 unit. So meaning we're going to have 1 here, 2 there, 3 there. We're going to have 1 here, 2 there, 3 there, except these are negatives. Okay, like that. So at this point I can now bring about my ruler and draw this particular axis. So my x-axis is going to be there, right there, up to there, and then my y-axis, just spin this guy around. Okay, somewhere there, and then we draw our y-axis a bit to the left, somewhere there. Just move it a little bit. Okay, so this is our y-axis. So this is y-axis, and then this is x-axis. Okay, so we have carefully interpreted the scale and we've plugged in our values. Now we can start plotting. So to plot, we're going to go back to our table of values here. So let me just put these coordinates down here for easy capturing. So I have negative 3, comma, negative 7. These ones right here. Remember, the one on top is an x coordinate, the one down is the y coordinate. Then we have negative 2, comma, 6. Okay, these ones right there. Next one we have negative 1, comma, 7, followed by 0, comma 2, followed by 1, comma, negative 3, followed by 2, comma, negative 2, followed by 3, comma, 11. We found the value of k as 11. So now let us plot this graph. So for this one, allow me to use a different color so that you can easily distinguish between the x-axis and the graph. So we start with this one. Where is negative 3, comma, negative 7? Negative 3 is right here. Okay, now where is negative 7? So this here is negative 5. You can see, if you go to the y-axis, that is negative 5 there. Okay, so now you need to figure out these small boxes. Okay, these small boxes, what are they representing? Okay, so if we are to move from 0, from here we're moving from 0 to 5, meaning these small boxes, what are they representing? Let's start testing. So if we say 0, 1, 2, 3, 4, 5, of course we have gotten to 5 before we get to the actual 5. So we increment. Let's make them 2s. Let me just clear that. We increment, we make them 2s. Let's try. If we say 0, 2, 4, 6. Okay, what did I do? If we make them we made them 1s, they didn't fit, so we increment. We say one box is it? If we say 2, what are we going to get? Okay, let's try 2 boxes. So this is 1, 2, 3, 4, 5. Okay, so meaning 2 boxes, it is going to give us 1. So meaning one small box is like 0.5 or something. Okay, so this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You have seen what we have done there. So we are now looking for negative 7. Okay, so we have determined that 2 boxes are equal to 2, meaning if this is 5 here, then this is going to be 6, and this one right there is 7. Okay, So therefore negative 3,7 is going to be right, wait a minute, this is 5, 6, 7 right there. So negative 3,7 is going to be that point there. Let me try, okay, yeah. So this is the line for negative 3 for the x-axis, and this is negative 7 for the y-axis. They are meeting right there. So that's where that coordinate is going to be. We're done with this one. We got the next one. This is negative 2,6. Negative 2,6. Negative 2 is this line here. Okay. Now, comma 6. So this is 5. So this will be 6 right there. Okay, this line is 5. You can see that that is 5. So meaning the next line here, that is 6. So remember, it's two boxes. So negative 2,6 is going to be there. Next one, we have negative 1,7. Negative 1, positive 7. So negative 1 is this line here. This is 6 here. Same line as that one. So meaning our 7 is going to be right there. Okay. Next one, we have 0,2. So 0 is on the x-axis, 2 is on the y-axis. So we're going to say 1, 2 right there. So 2 is therefore going to be, this is 1. Let me do it from the side so that I can easily erase without erasing the y-axis. Okay, so this is 0, 1, 2. So meaning our 2 is going to be there. 0,2 will be right there. We are done with this one. 1, negative 3. 1 is this line here. Okay, this line coming down here. That is our 1. And then negative 3. So this is negative 1, negative 2, negative 3. So 1, negative 3 is that point there. And then finally we have 2, negative 2. So 2 is this line here. Negative 2, where is negative 2? So this is 1, 2. So negative 2 is right there. That's our coordinate there. And then the last one is 3,11. So this is 3. This is 10. Okay, 10. Same line as this one. That's our 10. Okay, this is 3. So while these two are meeting, this is 3,10. Now we're looking for 3,11. So we need to go upwards by 2 boxes to get to 11. Okay, so those are the dots we're supposed to connect to come up with our graph. So try to be as neat as possible when you're doing this. Make sure your graph is smooth. It has smooth edges, not a graph in a corners. You don't have to use a ruler here. It has to be freehand. At this point, do you have any questions before I proceed to actually drawing the graph? Do you have any questions when it comes to tracing these coordinates? Okay, you know the drill. If you have a question, you can raise your hand, then I'll give you an audience, or you can type in the chat and I'll be able to see your question. I'll give you 10 seconds. Do you have any questions? This is very important. You need to be able to come up with these coordinates and be able to plot them on the graph. Okay, it seems there are no questions. So I'm now going to try and draw this graph. So we have there ambo bumping a graph yanga manch. Okay, let me try to do it smoothly. So oops, we have missed. Take it slow, and I'm coming downwards. I'm having issues on my tablet here. Okay, this one has missed. Let me try to do it again. Okay, let me take it up like that. So as you are drawing, you know to say it has to turn and go in this direction. So make sure you are going to do it smoothly. Try to be as smooth as possible. You know that it has to hit that point, so make sure as you are going, you should be going towards that point. Okay, something like that. But with a pencil, I expect you to be much smoother. So then you even name your graph. This is y is equal to what is the original equation for the graph, it is x cubed minus 6x plus 2. So this is x cubed minus 6x plus 2. Of course, you have to make sure that that name for the graph fits on your graph paper. Doesn't have to protrude even the x-axis, because we've been taught to answer this question on a sheet of graph paper. So we are done. We have gotten these 3 marks. So these 3 marks, how you are going to get them is going to be based on how neat you are. Also, when you are coming up with these dots, let's say these are your coordinates, don't make them so big. Make sure they are just nice and small, easy for you to see. Okay, don't make them too big. So by the way, you are supposed to use a pencil for this question, no pen. Okay, all the questions you have on this question are supposed to be answered using a pencil. So don't make a mistake and use a pen. You will lose marks for that. Okay, so we are done plotting the graph. We can now proceed to the next questions, which are similar to what we did yesterday, the other time in the other session. So use your graph to solve the equations. We have this one here, x minus x cubed minus 6x plus 2 is equal to 0. So this one, you notice, is the same as the equation for the graph. Okay, I can answer this one from right here, right up here. Let's see, we have okay, let's push it down there. That is Roman numeral 3a. So we said the first thing is write the original equation for the graph, which is x cubed minus 6x plus a 2, if I'm not mistaken. Yeah, and then next thing, you write the equation you're trying to answer, which is this one. Okay, so I'm going to say x cubed minus 6x plus a 2 is equal to 0. So this one has been excuse me, this one has been equated to 0. And remember, we said our goal is to make sure that the left part of this equation should match exactly the right part of the graph. Okay, so as you can see here, these values are matching. So if they are matching, what did you say you do? You need to cancel them out. Okay, then y will be equal to what is remaining on the right. So meaning here y is equal to 0. That is your inequality. So now we need to draw this inequality, y is equal to 0. So y is equal to 0 is just the x-axis. Okay, I'm sure by now you have figured this out. It's just the x-axis. Okay, but for the sake of learning, we are going to draw it. So I'll make it protrude this side so that I can easily delete it afterwards. Okay, that is y is equal to 0. Once you draw it, then you're just going to check where is this inequality y is equal to 0. This one, y is equal to 0. Where is it cutting through the graph? It's cutting through the graph at that point. Okay, at that point there and at that point there. So we just need to collect those x coordinates at the points where it is cutting through the graph. So if this here is -2, this is -2. I put the coordinates too far away, they seem as if they are belonging to other lines. Okay, let me just put them close. This is -2, this is -1 right there, and this is -3. Okay, so this is -2, and this is, if this is 2 and this is 3, meaning obviously so as you are buying graph papers for practicing, you do well to buy these graph papers. You can see in the center here there is a faint green line. Okay, it is darker than these other smaller ones, so that shows you the center of this entire block. So the center is there like that. Okay, the center between this one and this one is this one here. Okay, right there, this is your center here. So you can easily estimate to say if this is 2, this one is 2. Okay, I'm trying to avoid touching here because I will have a hard time deleting. I might end up erasing the inequality. So instead, now I'm trying to do it from the top here. So the center of this and this is right there. So that should be something like 2.5. Okay, so now we need to determine also on the what have I erased? The graph. Okay, we need to determine on the x-axis what each small box represents. So if this is 1, so meaning this will be 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, 1.9, 2, because there are 10 boxes between these two lines. From here to there, the 10 small boxes. So meaning 1.1, 1. So each box means 0.1. So this is going to be, this is the center of these two, right? So meaning obviously here it is 2.5. So I'm going to say 2.5, 2.6, 2.7. So that is our 2.7 there, this coordinate right here, where the inequality is cutting through the graph. So meaning we're going to say x is equal to negative 2.7. That is our first coordinate. And then we come to the second point right here. Okay, so this is 0, 0.1, 0.2 here, and 0.3 there. So we're going to say x is equal to 0.3, and you are done. I can erase those out. Oops. Okay, I think I can leave this guy. I keep erasing the wrong value. Okay, we go to the next one, which is this one here. So this is 2.1. We can round it off to 2.2, this one here. Okay, so meaning x is going to be equal to 2.2. So we are going to say x is equal to 2.2. Those are going to be your coordinates. I keep getting a notification here. Let me just check it out. Okay, I think we can proceed. Okay, do you have any questions at this point? Any questions? Okay, so if you have a question, please just raise your hand or post in the chat for the sake of being quick. So we now go to the next one, which is this one. Okay, so we said the first thing, write the original equation for the graph, which is x cubed minus 6x plus a 2, and then you write the one you're trying to solve, which is x cubed minus 6x is equal to a 2. So remember, we said our goal should be to make sure that on the left it is identical with what you have up here. So now you notice that the positive 2 is missing here. So what are you going to do? How are you going to move it to the left side? So all you're going to do now is you're going to say x cubed minus 6x and plug in the value that is missing, this positive 2. We have put it here. So now what you do on the left is what you should also do on the right. So on the right we already have this 2, so I'm just going to say plus 2. Okay, once we do that, it simply means that one and that one will cancel, that one and that one will cancel, that one and that one will cancel, meaning y will be equal to what we are going to get from here. So meaning y finally is going to be equal to 4, because 2 plus 2 is going to give us what? A 4. So now we need to draw this inequality, y is equal to 4. So we are going to go to our graph. Okay, if this is 5, meaning our 4 will be right there. Remember we said 2 boxes, it simply means 1. Okay, let's confirm. 1, 2, 3, 4, 5. Yeah, so our 4 is this line here. So we are going to go to that line and draw our inequality, y is equal to 4. So y is equal to 4 is going to pass there like that. That is your y is equal to 4. Then we need to collect the coordinates where this line is cutting through the graph. So this one we can round it off to this one. What is the x coordinate at that point? So this is let me try to solve it from here. This is negative 2, 2.1, 2.2, 2.3. So we're just going to say x is equal to negative 2.3, sorry, that was 2.3. We have captured the coordinate right there. we go to the next one, next point where the line is cutting through the x-axis, so it is this point here. We are going to round it off to this one. Okay, so what is the coordinate there? So we have 0, 0.1, 0.2, 0.3. It is this line we are looking for, not that one. Okay, I think it's closer to this one according to my graph. Okay, so we can count. That is 0.1, 0.2, 0.3, 0.4, 0.5, this one. So I'm going to say x is equal to negative 0.5. We are done. We go to the next point. So this point here, we check what is this line here on the x-axis. So if this is so that is definitely half of it's right between 2 and 3, so that's going to be 2.5. So meaning our x is positive 2.5, and we are done. Okay, we now proceed to the last question, which is asking us to find the equation of the normal to the curve. So the process of finding the equation of the normal to the curve is very similar to the one for finding the equation of the tangent. Okay, in the previous session we looked at those equations for the tangent. In this one they are asking us to find the equation of the normal to the curve. So to find the equation of the normal to the curve, you start with the same process. You are going to differentiate this function. When you differentiate this function, where there is x, you plug in the x coordinate to find the gradient of the tangent. So let's go ahead and do that. So we have y is equal to x cubed plus 3x squared plus 2. To differentiate, we say we multiply the power of x with the coefficient of x, so meaning we're going to say dy over dx is going to be equal to 3 times 1x to the power 3 minus 1. Here the power of x is positive 2, so we're going to say plus 2 times the coefficient of x, which is a 3 here. Okay, x to the power 2 minus 1. You take out 1 from the power of x. Differentiating a constant, it just becomes a 0. Okay, so meaning dy over dx will be equal to 3 times 1 there will give us 3x. 3 take away 1, that is going to be 2. Okay, 2 times 3 there gives us positive 6x. Okay, 2 take away 1 there is just a 1. So this is our differentiated function. So we're going to say gradient is equal to 3. Where there is x, we're going to plug in the x coordinate we have been given in the question. So negative 1 squared plus 6 negative 1. So our gradient is now going to be 3 times a 1, because negative 1 squared is positive 1, and then here we're going to say positive times negative there, negative, so that will be negative 6. So meaning our gradient is going to be 3 times 1, 3 minus 6, giving us negative 3. So now this gradient you have found is the gradient of the tangent as well as the gradient of the curve. So now remember we said the tangent and the normal are perpendicular. Therefore, you are going to now use this formula, which is m1 times m2 is equal to what? Negative 1. What you have found here is m1. So where there's m1, I'm going to plug in negative 3, and then I multiply. m2 is now the gradient of the normal. That is what I'm trying to find. So then I'll divide both sides by negative 3, both sides by negative 3, so that these can cancel and that can cancel, meaning the gradient of the tangent is going to be equal to 1 over 3, because that negative divided by that negative gives me a positive. So now this is the gradient of the tangent. At this point I am done. All I have to do is say y is y minus y1 is equal to m open bracket x minus x1. Why there is y1, I'm going to plug in the y coordinate given to me in the original question, which is a 4. Why there is x1, I'll plug in negative 1 there. Why there is m, I'll plug in this gradient I have found here, and then solve. The equation I'll find, that is the equation of the normal to the curve. So this is a process for finding the equation of the normal to the curve. For this type of the question, this is the one they like asking. They don't ask you to find the equation of the tangent, no. Okay, minus x1 is negative 1. So you can actually use a square bracket there and there. So meaning y minus 4 is equal to 1 over 3 times 1 times x is just going to give me 1 over 3x. Okay, then inside the brackets there, negative times negative will give me a positive. 1 times 1 will give me positive 1 over a 3. Y is therefore now going to be equal to 1 over 3 x plus 1 over 3. This negative 4 will cross the equal sign, it becomes a positive 4. Okay, at this point I'm now going to say y is equal to 1 over 3 x, and then here I'll say over 1, common denominator is a 3. 3 into 3 is 1, 1 times 1, 1. Bring down that positive, 3 divided by 1 is 3, 3 times 4 is 12. So that will give me, let me push it a little downwards. So meaning our y is going to be equal to 1 over 3x. 1 plus 12 there is going to give me positive 13 over a 3. This is the equation of the normal to the curve, and you are done. Do we have any questions? We're done with question 1. So you solve it this way, it simply means you've earned yourself about 10 marks, considering the neatness here when you're drawing the graph. Okay, roughly 10 marks, 11 marks out of 12. Okay, depending on how neat you are. If there are no questions, we proceed to the final example, which is this one here. Answer this part of the question on a sheet of graph paper. Same applies to what we did in the previous example. So same format again, they'll give you a table of values, hide one of the values. So one of the values here has been hidden and represented by the letter Q, as you can see here. I don't know if you can see, it's a bit faint. So first thing first, get the equation of the graph, which is y is equal to negative x to the power 3 plus x squared plus 6x. Okay, where there's x, plug in the corresponding value to the hidden value. So we're going to say y is equal to negative, that is going to be 4 to the power 3 plus 4 squared plus 6 4. Okay, we punch that on your calculator, don't waste time solving them one by one. So negative 4 to the power 3 plus 4 squared plus 6 times 4, close. I confirm that I've punched the correct values. Negative 4 cubed plus 4 squared plus 6 times 4 equals, that gives me negative 24. So if I want, I can even say therefore, actually you should, since they're asking me to find the value of Q, so I'm going to say Q is equal to negative 24, and you are done. We now come to the interpretation of the scale. They are saying using a scale of 2 centimeters to represent 1 unit on the x-axis. Okay, so meaning it's 0, 1, 2, 3, like that on the x-axis. 2 centimeters to represent 1 unit. On the y-axis, so the range is from negative 3 to positive 4. Okay, the furthest number on the left should be negative 3, on the right 4 for the x-axis. And then we are told to say 2 centimeters to represent 10 units on the y-axis, meaning it's going to be 0, 10, 20, okay, negative 10, negative 20, and so on and so forth. 2 centimeters to represent 10 units on the y-axis. Okay, the range is from negative 30 to positive 20. Okay, so for this question, usually I like centering it. So I can simply say, so the positive for the y coordinate is 20, so I can put my 20 here, positive 20, so it's 10 units. All right, so here we're going to put a 10, and then here we're going to have a 0. Okay, up to what? Negative 30, going downwards up to negative 30. So we scroll down, so meaning here we're going to have negative 10, negative 20, negative 30. Okay, for the y-axis, what is the range? The range is from negative 3 to positive 4. Negative 3 to positive 4. So on the left, we're going to go, we have negative 1 here, negative 2, negative 3. On the right, we go up to positive 4. 1, 2, 3, and 4. Okay, then we draw our graph. So for this one, again, let me use a black pen so that we can be able to clearly see the y-axis. So we get our ruler, put it right there, put it at 90, somewhere there, and then we draw our y-axis, and then we turn it around so that we can draw our x-axis. Bring it down here. Okay, somewhere there, that is our x-axis. Okay, we can bring it down here. Okay, so going up here, this is your y-axis, and then this is your x-axis. All right, we have interpreted our scale. Now we start plotting the coordinates. So let us just bring the box a bit downwards here. So we have let me put them here. I will have to erase them afterwards. -3, 18, these coordinates here. Then we have -2, 0. I have -1, -4, and then I have 0, 0. Then I have 1,6, 1,6. I have 2,8, and then I have 3,0 and 4, -24. Remember, we found the value of q as -24 there. So at this point, we can go ahead and draw our graph. But first we plot the points. So let me change back to red. Okay, so the first coordinate is -3, 18. -3 is this line here. Where is our 18? Okay, so remember there are 10 small boxes, so meaning this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, this line here. Okay, so meaning this is 20 here, we're looking for 18, so we simply have to drop, this is 19, 18. Okay, so 18 is right there. -3, 18 is right there. And then -2, 0, -2, is just right here on -2. Then we have -1, -4. -1 is this line here. Where is -4? So this is -5, right? -4 obviously will be up here. Okay, let me write the 1 properly so that it doesn't obstruct my point there. Then we have 0, 0. 0, will just be right here. And then 1,6. So 1,6, this is 5. Okay, so meaning 6 is this line here, this line. So 1,6 will be right here. We're done with that one. 2,8, 2,8. If this is 10, then this is 9 and this is 8. Okay, so 2,8 will be right there. 3,0 is right here at 3. Okay, that one is not bad, not nicely plotted, so our 3,0 is there. And then we have 4, -24. 4, -24. -24 should be down here. This is -20. This is 4. Okay, so 20, 21, 22, 23, 24, right there. That is where our 4, -24 is. So now at this point we simply join these dots. So let me change back to a black pen so that I can write the coordinates with a black pen so that you can clearly see the dots. So this is -1, -2, -3. Then here I have 1, 2, 3, 4. 1, 2, 3, 4. I want you to be able to clearly see the coordinates, the dots for the graph. So we have 0 here, -10, -20, -30. Going upwards, we have 10, 20 there. So this is 10, this is 20. Okay, you can now clearly see the dots. So the graph will go something like, wait a minute, I think we've made a mistake here. That is -3, 18. The 18 is a positive. Okay, let me just show you something. And that's napange sense graph. Okay, 18 here is a positive. Positive 3, 18. Tafaka -3. That's -3, 18. Instead, what I've put is -3, -18. That is why the 18 is down here. So this coordinate is -3, -18. What we need to plot is -3, +18. So if this is 20, this is 19, 18 will be right there. Okay, so that the graph comes down like this, then it goes like this, and then comes down here. Okay, so let's get to the problematic parts. So we go like that. So take your time, make sure you try to be as neat as possible. So I'll turn it there. Okay, okay, let me do it a bit better than that. Okay, my hand is, try to clean my hand a little so it can easily slide on the tablet. Okay, let me leave it there first, and then I lift it there. Oops, okay, that is bad. So it needs to start turning quite early since it's going like this side. So it needs to start turning quite early. So if I take it down, and then oops, this is not easy doing this using this tablet. Okay, let's try again. Try to condense it like that. Okay, no, take it a bit downwards and then turn it like that, and then there it starts bending downwards. Stop it right there, and then we drop it to this guy. Okay, here it seems so straight. Here we can do better at this point here. Okay, otherwise try to be as neat as you can. Here it seems a bit cornered, it's not curvy. It's supposed to be at least curvy as you do this. Yeah, so this is the best I can do for now. All right, we now go to the next question. So remember to name your graph. The name of the graph is y is equal to, what was the name of that graph? X cubed plus x squared plus 6x. So that is x cubed plus x squared plus 6x, right? Let me just confirm. Okay, x cubed plus negative, actually negative, not positive but negative. So we erase these guys, and this one, this is negative x cubed, so equals y there. The line can go there. We are done. We now proceed to the next question. Use your graph to solve the equation. So I have this one here. So remember we said the first thing is write down the original equation for the graph. Excuse me, which is x cubed plus x squared plus 6x. This is our equation for the graph. Negative x cubed plus x squared plus 6x. Then you write the one you're trying to solve, which is this one here, which is negative x cubed plus x squared plus 5x is equal to what? Is equal to a 4. minus x. So you notice to say our goal has not been achieved. We said on the left it has to be the same as what we have there. So instead of having 6x, we have 5x. So meaning we need to add an x to the 5 to get to 6x. So we're going to say negative x cubed plus x squared plus 5x plus x, so that we can get to what? We can get to 6x there. But we said what you do on the left is what you should also do on the right. So we're going to say 4 minus x plus x. Here we're just going to get a 0. Okay, so meaning we're going to say x cubed plus x squared, 5x plus x gives us 6x. Here we're just going to remain the 4 because these values will cancel out this here. So now at this point you notice to say we have negative x cubed there, negative x cubed, x squared, 6x, 6x. So these values can now cancel out. So meaning that cancels that one cancels that one cancels that one, meaning y will now be equal to what? This guy right there. So the value of y, the inequality is just going to be y is equal to 4. So at this point we go back to our graph and we draw y is equal to 4. Where is y is equal to 4? Y is equal to 4 is going to be right here, somewhere here. Okay, a bit downwards, somewhere right. Okay, somewhere there, yes. So you draw your inequality, this one. Okay, y is equal to 4. Then you check why it's cutting through the graph. So we drop down here, we need to check what is the coordinate there. So this is a -2, -2. This one is too far away. Okay, -3 is right there. Okay, so -2 is here, 2.1, 2.2, 2.3. So we have 2.3 here. So I'm going to say, okay, let's put it even here. Okay, but you know you need to arrange these values nicely, preferably under your solution there. So we're going to say x is equal to -2.3 as the first coordinate. The second point is cutting through the graph is here. Okay, what is that coordinate there? So this is 1 here, so meaning 1, 0.9, 0.8, 0.7. So I'm going to say x is equal to 0.7. That's your second coordinate there. Let me clean up even here and there. Okay, the next one, what do we have? What do we have right here? Okay, what is the x coordinate at that point? So this is 2.5, 2.6, right? This one here is 2.6. So I'm going to say x is equal to 2.6, and we are done. We go to the next question, which is again asking us to find the equation of the normal to the cave at the point 1, 4. I think this one is slightly longer than the one for finding the equation of the tangent. That is why people get to have problems with this one. So I need you to master it. You can't afford to miss these 3 marks. Very simple 3 marks. You know everything you're supposed to do. You know how to differentiate. You know how to find the equation of a straight line. So why should you miss out on these 3 marks? So we said the first thing you do is you write down the equation they've given you of the curve, which is x squared plus x plus 2. This one is very simple. Okay, then you differentiate it. So dy over dx is equal to 2 times 1x2 minus 1. Okay, what's the power of x there? It is 1. So we're going to say positive 1 times 1x the power 1 minus 1. Differentiating a constant, it becomes a 0. So meaning dy over dx will give you 2 times 1. Oh, this one doesn't look like 1x. Okay, 1 there. 2 times 1 there is a 2. X the power 2 take out 1 is a 1 there. Okay, 1 times 1 there will give us a 1. Okay, x minus that is x the power 0. 1 minus 1 is 0. Then what do you get there? We're going to say 2x plus 1 times 1, because this x to the power 0 will convert to a 1. Any value raised to the power of 0 is 1. So a differentiated function is just 2x plus 1. So at this point we can now say m is equal to, so this is dy over dx and dy over dx over dy over dx. So m is equal to this same differentiated function. This is your differentiated function. So now we're going to say where there is x, you get your x from here, okay, you put it in there. So 1 there plus 1, meaning your gradient is going to be 3. Okay, 2 times 1 is 2 plus 1, that is a 3. Now this one you have found is a gradient of the tangent. So gradient of the tangent. We now need to find the gradient of the normal. So gradient of the normal will be equal to what? So we are going to employ that formula, m1 times m2 is equal to -1, coordinate geometry. m1 is a gradient of the tangent, which you have as 3, times m2, which is gradient of the normal. That is what you're trying to find. You divide both sides by 3 by 3. The 3's cancel, meaning gradient of the tangent is going to be equal to -1 over 3. Having found that gradient, you can now say y minus y1 is equal to m x minus x1. Okay, while there's y1, you plug in the y coordinate you have been given in the question, which is a 4 there. While there's x1, you plug in the +1. While there's a gradient, you plug in the gradient you're just from finding, this one, gradient 2. Then you solve. So then it's going to be y minus the y1 is 4 there, right there you can see the 4, is equal to, gradient is -1 over 3, okay, then x minus 1, okay, the x coordinate up here is a 1. Then you solve. Y minus 4 is equal to -1 times -x will give us -1 over 3x there. Negative times negative there is a positive. This negative times this negative. 1 times 1 is a 1 over a 3. You group the like terms. Y is equal to -1 over 3x plus 1 over 3 plus a 4. This 4 is a negative. When it crosses the equal sign, it becomes a positive. Okay, once you do that, you're now going to say y is equal to negative. So for that one, we can actually do this. We can say over 1, and then we come up with the common denominator, which is a 3. 3 into 3 is 1. 1 times 1, 1. Bring down that sign. 1 into 3 is 3. 3 times 4, 12. These questions are very similar. You remember even in the previous one we had a 13 on the other side. Okay, so that will give us plus 1 plus 12 there is 13 over 3. Yeah, I think we found the same thing. And you are done. You have gotten about 10 marks. Okay, where is our 13? Yes, right there. Same answer, except here the gradient is a negative. In this question it's a positive. Yeah, so you can see, as simple as that. This can only become simple when you are practicing. Okay, watching videos or following through lessons online is not enough for mathematics. Okay, it's different from these other subjects. Yama notes are, you can easily remember, oh, biology, an enzyme is what, but mathematics method ikaenda and chiaenda doesn't come back anyhow. You can only sustain it by frequently solving. So make sure some of you don't submit assignments. Okay, of course I apologize for those whose assignments have not yet marked, but yes, some of you, allow me to now say this, some of you don't submit assignments. Okay, it simply means you do not try out these questions. If you are not trying out questions, you remember my words in the exam room, and I wish you don't get to that extent where you start remembering. You say, maybe if I was solving, I would have remembered this, because you notice to say everything you find in the exam room would be familiar, things that you have already seen before. But the problem is that you didn't attempt to solve. That's how come you won't be able to remember them. So to make sure that you remember, start solving now. And like I mentioned earlier on, right at the beginning, if you know to say you are lagging behind, yes, you could have been learning, okay, right from when we started, but you may not have been doing your honest part. This program that I have come up with, the crash course, is meant to help such a one. who knows deep down their heart that I'm not ready yet, okay, I need some extra help. So this is meant to help you. Each crash course is only 30 kwacha. For you guys who in my class, there's nothing like early bed. I can even give you at 30 kwacha each, okay. But for those one outside my class, once it hits 10 students, then they will be paying a 40 kwacha each. So this program is meant to help you. So you know yourself, you are able to tell, to say, how am I doing? Okay, when you start solving an exam paper, are you able to solve a complete exam paper? Or are you able to solve everything we have covered? If you know you are unable to solve, then this, don't make sure that you jump on this. It's going to help you a lot. I'm going to try as much as possible to simplify concepts so that we can be able to cover these topics that I have indicated in the hours that I have indicated. So this will be a very good refresher course, even if you have covered this. If you know to say I'm not there yet and you want a distinction, make sure you jump on board. Otherwise, that is all I had for you in this session. Thank you for watching, and thank you for your time. For those that are watching this recorded video, thank you for watching. Yeah, so in the next session now, we're going to look at the last topic in section B. The last topic is going to be linear programming. So linear programming is some form of an extension of this one, cubic functions, because there you're going to be interpreting the scale. There's also going to be coordinate geometry, because you're going to be dealing with inequalities. Okay, so that is why sometimes as you are choosing questions, you have to be strategic. These two questions are very similar. So imagine you choose one of them and then you go to something totally different, like let's say statistics or transformation. Transformation also has a bit of linear programming and all that. So GCE mathematics is very simple to pass. You just have to be strategic. Okay, that is why I chose these questions, because this is, according to me, the best way you can tackle section B. So otherwise, let's get ready. I want to see those graph papers neatly answered as you submit the assignment I'll give you tomorrow, because for this one they also mark your neatness. Okay, so that is that. I'll see you in the next session. Enjoy the rest of your evening, and good night.